Morning. Honors Algebra 1, we're going to take a look at your 9.5b samples where we're graphing quadratic equations either presented in vertex form or we will use complete the square process to rewrite our quadratic equations so that they are in vertex form. And from that we will make our graphs. So here's our first equation. This one does happen to be presented to you in vertex form. Where we can identify the vertex of the equation simply by looking at the equation. If you'll recall, if we find the number that is opposite what we see in the parentheses, so we see minus 4, the opposite of that will be positive 4, and then whatever number is outside the parentheses, that will be the same for your y-coordinate of your vertex. So opposite of negative 4, positive 4, same as negative 3, negative 3. And that's just by looking at the equation because it is presented to us in that special vertex form. So we're going to write that vertex in the middle of our table of values, 4, negative 3, no work to do here because we've already pulled off that information right from the equation. Then pick an x value smaller than 4 and bigger than 4, and you're going to work out your corresponding y values for those x values you've chosen above and below 4. And of course we want those y coordinates to be the same because there is symmetry involved here. We want to be at the same height on either side of our vertex when we plot those points. So here we are plotting the vertex at 4, negative 3, 3, negative 1 to the right, 5, negative 1 to the left, and drawing our parabola through those points, opening upward. So again, our parabolas will have the shape of a V with a rounded bottom, and that's what we have here. Our next sample, sample 2, which will be our last sample today. We are to graph the quadratic equation by completing the square. So there are a variety of different ways that you could use to graph this quadratic equation, but we're asked specifically to use completing the square method, so that's what we're going to do here. To complete the square, we're going to add a box to both sides that at first will be open. There'll be nothing in those boxes. We're going to add the same number to both sides to keep this equation true. To figure out what goes in this box here, we're going to divide our coefficient on our x term by 2. Negative 4 divided by negative 2 is negative 2, or we'll think what is half of negative 4, that's negative 2. Then we will calculate that negative 2 squared, and that will go into both boxes. We're going to add 4 to both sides. And the reason that we've done that is we now have a perfect square trinomial here that we can rewrite as the square of a binomial, and that's what we're doing, coming from this trinomial down to the square of the binomial. That minus 2 pops right inside of your parentheses that we're going to square, and we now have y plus 4 equals x minus 2 quantity squared plus 5. Then we subtract 4 from both sides, and we'll arrive at our equation in vertex form, y equals x minus 2 quantity squared plus 1. We can look at the equation now in vertex form, and we can identify the vertex. Opposite of negative 2 is 2, same as 1 is 1. So opposite, same for the numbers we see in our equation in vertex form. We're going to make our table of values, and in our table of values we're going to put the vertex in the middle. X is 2, y is 1. We'll pick x values bigger and smaller than our x is 2. Find the corresponding y values that match to those x values, and then we'll go ahead and graph that. From our table of values, we'll graph that parabola, and here we are. On the left here, we have 1, 2. Our vertex is at 2, 1, and our point here on the right-hand side is at 3, 2, and that completes our graphing of our quadratic equation using the technique of completing the square. Please make sure these samples are on your lesson work. Review the samples in preparation for today's quiz, and we'll see you next time.